So yesterday we talked about function notation here, algebraically speaking. And what we discovered was that the only difference now is instead of writing y, we are writing f of x. And all of you were quite comfortable with the fact that these do no longer say f of x, they say f of 2. So the 2, this x, oh shoot, I should have been using green. This 2 replaced this x right there, so that 2 replaces the x in there. We get an input of 2 and an output of negative 3, which are x and y on the graph. 2, negative 3, that dot. All right? That's where we stand right now. I know that you cannot believe it could possibly get any more complicated. It can't. Okay? That's all that's going to happen for the next little while. What is going to make things weird is things like that. It's a fraction. Does that change anything? No, of course not. So, this function is named g of x. So we have been tasked with finding the g of 6, the g of negative 3, and the g of 0. This is not complicated because instead of an x, what do we have to put? 6. So we will start with the g of 6, and we will rewrite. It is no longer negative 2/3 x. It is negative 2/3 times what? 6 plus 1. Now, I'd rather not have to do a lesson on multiplying because you're in the 10th grade. So I'm going to silently sit here for a moment and wait while you all write down this result. Write it lightly in pencil if you are not sure. Because I need to see if I need to do a lesson in multiplying. I will wait 10 more seconds while you decide if you can multiply negative 2/3 times 6. Now, I'm not going to put anyone on the spot, but this is negative 4 plus 1, which is negative 4 plus 1 is negative 3. Now, you do not need to say so out loud, but this becomes negative 12 over 3, which is negative 12 divided by 3, which is negative 4. Everybody should be good now. You all should remember the 4th grade now. Okay. Now, do I have an x and a y? What is the x value? What is the y value? On the graph, I go out to 1, 2, 3, 4, 5, 6, and down 1, 2, 3. And there is my first dot. Does everybody understand? Great. Now let's use blue. I don't want the g of x anymore. What do I want the g of? Negative 3. So it becomes negative 2 over 3 times negative 3 plus 1. What does this become? Positive 2 plus 1, because the 3's cancel, and a negative times a negative is a positive, which gets me 3. What is my point on the graph for the blue one? Negative 3, 3. 1, 2, 3, 1, 2, 3. And then the green one, which I am out of room, so I'm going to slide over here. I want the g of 0, which is negative 2/3 times 0 plus 1, which is 1. What is the xy value? 0, 0, 1. And now, all those three make a nice line. Why do I get to connect the line? Because this is continuous data, isn't it? Can I put any number in for x? Any number in the universe, even a fraction. And I will get an output, won't I? And whatever x I put in there, the y will be that value. Everybody good? Okay. Now, please notice that up until now, we have always been given a g, right? G of x, g of 6, g of x, g of negative 3, g of x, g of 0, yes? What's different in number 4? What is missing? I know the y value. I do not know the x value. So everybody put a line in the middle of your paper. This side is algebra. This side is going to be graphing. Now, you're intelligent young people. When I write g of 6, what has changed from the original equation, which is right there? What has changed when I put a 6 there? The x is now a 6, yes? Which means what is going where that x is? 6. Everybody cools. Everyone's cool with that, right? Well, now I have this. G of x equals 7. Right? Well, the g of x equals negative 2/3 x plus 1, right? But doesn't the g of x also equal 7? So, g of x also equals 7. So what does that tell me about 7 and that? I heard someone whisper it. Be strong. Gersil? Why would you need to do trial and error? The g of x is this yellow box. The g of x is 7. So what else do you know? Braden? You're right, but you're not answering my question. You're doing the first step of the work. Amelia? They are the same. The g of x is this yellow thing. The g of x is this blue thing. So does that not mean that the blue thing equals the yellow thing? Okay, so what is the blue thing? 7. What is the yellow thing? Negative 2/3 x plus 1. What's your job now? What's your job anytime in math that you see a letter in an equation? Isolate it. And that makes sense, doesn't it? Because in this case, we didn't know the x. So Braden says I got to take away 1 from both sides because he was doing the first step. He had just skipped over what I was asking. -1 minus 1. 6 equals negative 2/3 x. Now what? Not quite. Gersil? I would multiply it by negative 3 because we also have to get rid of this negative, don't we? Negative 3, which means what do I got to do to this side? So what's negative 3 times 6? Negative 18 equals, and what's left over here? No. Negative 2x. Now what's our last step in algebra? divide by negative 2, because we want to get rid of the negative as well. 9 equals x. Now, what is our point that would be on the graph? 9, 7. Except, wait a minute, I screwed up right here. Should that negative be there? No, because we multiplied by negative 2. So that should be positive 2. So I should divide by positive 2. So that should be negative 9. Everybody cool? Except for that little mistake. Everyone's cool? So now we know that this xy will also work up here, won't it? Right? Okay, that was algebra. Now, if we're going to do it on a graph, is this gx equals 7? Is that a y or an x value? That is a y value, correct? Everyone agrees? So where is the y value of 7 on this graph? Is it somewhere on this uppy-downy line, which is vertical, or is it somewhere on this horizontal line? The vertical one. Where is 7 from 0? Up 7. 1, 2, 3, 4, 5, 6, 7. So there, somewhere on that line. Now pretend we haven't done the algebra, right? Okay, now what do we know about a line? It continues forever, yes? So this line, I went 3 to the left and up 2, right? So the next dot is going to be 3 to the left and up 2, isn't it? And the next dot from there is going to be 3 to the left and up 2, isn't it? And is that on my line right now? So I've got my y equals 7. What don't I have? Remember, we haven't done the algebra. We're pretending we haven't done it. I have a 7. I don't have an x. Where do I find the x, Braden? On the x line. And I count negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. Negative 9, 7. So I can find it by counting on the graph, or I can find it by using algebra. Do you have to be able to do both in math class? Yes. If you end up in a job where you are dealing with data graphed, do you necessarily need to be able to do both? No. Everybody cool? All right, so let's try a second one. Do I have a graph in number 5? So what is my only option? Algebra. So let's start. I have 3 choices. I got to do this red one, I got to do this blue one, and I got to do this green one. In the red one, do I have an x or a y? I have an x, so I'm going to have m7 equals, and what do I write? 4/3 times what? 7 plus 2. Now I'm going to stop there because some kid always says after this, they wait till I do all 3 pages, and then they say, I have no idea what's going on. So I'm going to stop right now and give everybody a chance to say, I have no idea what's going on, before I do 3 more pages of work. Can all of you see that this x has now become a 7, which means this x must also become 7? Do you understand that? Excellent. Now, ladies and gentlemen, do you see this next unit that says graphing linear relations? And do you see this next unit that says writing equations? And do you see this next unit that says systems? All of those units require you to understand this concept. When x changes to a 7, every x changes to a 7. Complicated? No. So we should be okay for the next 3 units, shouldn't we? Let's go. Why is this going to be tricky? Because I'm going to get 28 over 3 plus 2, aren't I? And that makes all of you lose your bladder control a little bit. Except it shouldn't. Because how many 3s go into 28? 9, with how many 3s left over? 1. So that is 9 1/3 plus 2, isn't it? What is 9 plus 2? 11. So what is 9 1/3 plus 2? 11 1/3. What is the point on the graph? It will be in the form, as always, of xy if it's going on a graph. What will it be? Jacqueline? 7, 11 1/3. Right? Easy peasy, lemon squeezy. What are we doing for blue? What does x become? 1. So what do I write? 4/3 times what? 1 plus 2, which is 4/3 plus 2, which is 1 1/3 plus 2, which is 3 1/3. What is the point on the graph? 1 and 3 1/3. Now, you all, I know, hate fractions, but this concept is really easy, isn't it? You see an x is now 7, so every other x is 7. It's pretty simple, yeah? So I'm putting fractions in here to get double, I'm going to say the word, double duty from this concept. Because the concept is easy, but I'm also reinforcing fractions here, yes? All right. So what's weird about the green arrow? I have the y. So mx equals 4/3 x plus 2. But mx also equals 5. Where in here does the 5 go? He waited patiently. Which is which? This part. So what am I going to write here? M of x is 5. That is m of x, yes? So 5 equals what? What do I write here? 4/3 x plus 2. Because I don't have an x value. And what is my job whenever I have a variable that I do not know? Isolate it. How am I going to isolate that variable? Well, I got to get rid of this plus 2. Minus 2, minus 2. 3 equals 4/3 x. How am I going to get rid of divided by 3? Times 3. 9 equals 4x. How am I going to get rid of times 4? Divide by 4. 9/4 equals x, which is 2 1/4. What is my point on the graph now? This one always screws kids up because they always write it wrong. What is this point on the graph? Gersil?
2 1/4, 5.
Yes. They all want to write this backwards because up here they saw a 5. But none of you are going to do that, are you?
Probably.
I know. Every year I do the same thing. None of you are going to do that, and the whole class says, no, never, Mr. Myers. And then on number 6, when I say go, what are you going to do? They do it. Are we on number 6? Go! Do the colors help for this? Okay, I'm going to turn off the screen so you are not staring at my work, but I'm going to keep working and it will all record. Okay? and I'll do every step. Like a ninja. They're doing something. They want to prove me wrong. We just did a function notation, and we did where we had g of x equals 5, so they're working backwards, and every kid always, when they have to write the point, writes 5 comma the x, and they all said they wouldn't do it. So I said, prove it. And now they're quietly trying to prove it. They think they are, but they wisely said they will probably still prove me right. I know that's what I said. You would wisely say that. But I'm hoping that you do prove me wrong. Before I turn the screen on, would anybody like to say any one of the 3 points that I asked you to find? Just the ordered pairs. You don't have to talk about the work. Just tell me your x and y values. Any one of the 3. Which one? What do you think it is?
2, negative 2, and 1. I think I multiplied the fraction.
That's okay. We'll sort it out. Amelia. Sure. 0 and negative 4 is indeed the last one. Jacqueline. Negative 2 and negative 3.5 is indeed correct. And Braden, all you did wrong was your subtraction of fractions. Here's what it looks like. So, Braden, you got to here. 2 times negative 1/4 is negative 2/4, which is negative 1/2. The negative 1/2 minus 4. You got to keep getting negative.
Oh, I see.
Right? If I have 2/4, I have 1/2, right? If I got 2/4, I got 50 cents, which is $0.50. Which right now is my favorite joke in 7-Eleven, because if you take your own cup, they sell you the coffee for 50 cents. So they say they're half loony with their coffee refill prices. Get it? Because 50 cents is $0.50. What?
I have a question. So instead of putting negative 4, can you put negative 1/2? Like positive 4 and negative 1/2?
Where?
For the first one.
What? I don't even know what you're asking, Gersahil.
Can you make the fraction negative instead of the whole number?
No. Are we all good? You're intelligent young people. What have we just practiced 1, 2, 3, 4, 5, 6 times? Algebra or graphing? Algebra. What do we need to practice now? Yay! I know you're all as happy as I am. Turn the page over. Now for you people, the colors don't work, right? But they've been labeled. The curvy line is the F. of x, and the straight line is the g of x. But for me, I can show colors. Everybody good? All right. So for this question, I'll highlight in yellow. Am I working with the curvy line or am I working with the straight line? How do you know you're working with the curvy line? Because it says f. This function is named f. Everybody cool?
Yeah.
Now, is this value an x value or a y value?
An x value.
How do you know it's an x value?
Because when it says f of x, the negative 3 is replacing the x.
Nice. According to this, x now equals negative 3, right?
Yeah.
Hey, Mr. Keeley, they did it right. Oh, I know. Well, to be fair, this isn't like the NHL. Nobody gets fired when the team sucks. The coach doesn't get fired. Just like the coach doesn't get, Yeah. All right. So where on this graph would I find the value of x equals negative 3? It's Halloweeny time. Somebody, like a Ouija board, where is x equals negative 3?
Negative 3.
Where do I go?
Back 3.
Back?
The left.
Oh, left. Okay. Left 3. Oh, it's moving. Who's pushing it? Aiden, are you? Braden, are you pushing it? No. Brody, are you? Who's pushing it? I don't know. I know. It's super scary, right? There is my x value.
It's negative 3, negative 2.
Now, where do I need a y value? On the straight line or the curvy line?
Curvy line.
Because I'm dealing with f, so I got to find a y value. Are there any y values up there? No. So where do I go?
Down.
Down there, and I find it right there. What is that value?
Negative 2.
So the f of negative 3 equals what? Negative 2. Does everyone understand?
Yes.
All right. In B, am I working with the straight line or the curvy line? The straight line. What is that? An x or a y value? And what does that x equal?
0.
0. Where is x equals 0? Right there. There is my x value. Now I need a y value. On which line? The curvy line or the straight line? Are there any y values down there? No. So where do I go? Up until I hit my line. What is it?
2.
2. So the g of 0 equals
2.
2. Oh. You guys try C. X equals what? So where do I go? To negative 2 and down to. So when the f of negative 2 equals negative 3. How many people are feeling confident? How many people are feeling like they've moved in next door to confidence? How many people feel that confidence lives way out in the suburbs in a really big rich house and you can't afford to get there?
I like the graphing more than the algebra.
Yes, because all of you were scared of algebra. Even though,
I don't like fractions. When it's normal numbers, then I like the algebra. But when it's fractions, I just don't like fractions at all.
but you can always get rid of a fraction.
I know. I just don't like them.
Okay. Fractions are one of the few things in the world that you can just get rid of. If you don't like your next door neighbor, you can't get rid of him.
I mean,
No, you can't. All right. Okay, gentlemen and ladies, what differs in D? I have a y value. So in D, y equals 1. So where do I have to go? I got to go to 1 on the y-axis. And that's pretty lucky because it's sitting on the curve, isn't it? What is the x value? I know the y value, so now I got to find the x value.
0.
Where do I find it? Right there. 0. So when the f of x equals 1, x equals 0. Yeah? All right, now this is where it's going to get the beginning of tricky. Let's look at e. Is that an x or a y value? That's a y value. And what is that y value? So where do I go? Up to 3. And then I need an x value on which line? The curvy line or the straight line? There. What is the x value? So x equals -1. Is everybody good to there? All right. You do f. Is that an x or a y value? Go. No, go. Don't say it out loud. Do it. And what is my answer? -2. Is everybody good? All right. Now something weird is going to happen with G. It is a little bit scary. It's not. Is this an x or a y value? Y equals -2. So where do I go? I go down to -2, correct? Now I need an x value, right? On which curve? The curvy curve, right? So is there one of them? But what happens over here? There's another one. So what are my x values? -1 and -3. And that's about as hard as this gets in the 10th grade. I'm serious. No, you wouldn't bother. But that's fine. Everybody cool? Right? Like this is really about as hard as this gets. Instead of y, we write f of x. And instead of writing x equals 4, we write g4. Because that should be an x, and that x equals 4. Complex? No. Make sure you're able to do it both ways, though. Are you allowed to have a preference? Yes. But make sure you can work with both. Just like every smart person prefers Coke to Pepsi. But when you go to Boston Pizza, you're stuck with Pepsi. No matter what the commercial says, is Pepsi okay? Well, I guess it will have to do. Not like Steve Carell says, is Pepsi okay? No, it's not. But since you guys work with Pepsi, I am forced to drink Pepsi when I come to your establishment. Yes, Pepsi is awful. My son prefers Pepsi. Now, here's something that's funny. Well, it's not really funny. Haha, it's kind of weird. So, in my house, my whole family, except my son, prefers Coke to Pepsi in cola form. Everybody with me? Okay, everybody good?
Specify that because he's recording.
Now, for clear sodas, right, we all prefer Sprite to 7-Up. Sprite is the Coca-Cola product. Except, again, my son. He likes 7-Up. Wait for it. We go to Ecuador. In Ecuador, and in many Latino countries, there is another type of cola, or another type of soft drink. It is yellow. It looks like urine. And it has, just like here, Coke and Pepsi, there are two choices. There is Inca Cola, which is the Coca-Cola product, and it is delicious. It tastes a little like bubble gum. And there is Cola Gallito, which is the Pepsi product. Everybody with me? Of course, when we go to Ecuador, me, my wife, and my son prefer Inca Cola, which is the Coke product. My daughter prefers Cola Gallito, which is the Pepsi product. Now, my wife and I don't give my son a hard time, but my daughter is a real to him about liking Pepsi. She's like, stop it, Pepsi's gross, man. But when we went to Ecuador, Beth was always like, we'd always like, yeah, get some Inca Cola. And Beth's like, get Cola Gallito. And then we get back to North America, to Canada here, and the only one we can get is Inca Cola. We can't get Cola Gallito. So my daughter is very sad. But then we give her a hard time. If you want to try Inca Cola, you know the Pan Asia Market up there across from City Hall? They sell Inca Cola in cans. I highly recommend it. It's delicious. Now, Carmen, have you actually been to El Salvador? No. Okay. It's super good. So if you find yourself near the Pan Asia Market and you're going in for a Vietnamese sub, a banh mi, they're delicious. I can't eat them anymore. I'm very sad about that. But if you find yourself near there going for a Vietnamese sub, get yourself an Inca Cola instead. It's delicious. And that's the end of my story about Coke and Pepsi. Oh, Dr. Pepper's way better than Mr. Pibb. Mr. Pibb is Coke's Dr. Pepper in the States. They don't have it up here. No, it's a Coke product. Just like Mellow Yellow is Coke's Mountain Dew in the States that we don't have up here. Because Mountain Dew is a Pepsi product. But when you go to the States, you can get Mellow Yellow, which is Coke's version of Mountain Dew, which, again, that one, it's almost the exact same. Like, I can't even tell the difference. But Mountain Dew in the States has way more cool flavors, like Code Black and all those things. They don't have them up here. Not all of them. They have some, but not all. But yes, I'm not a Mr. Pibb man. But again, when you're at Wendy's, you take what you can get. But now all the Wendy's have those cool mix the drinks all you want. And then, of course, the only drink to get is either vanilla Coke or raspberry ginger ale. You have endless flavors and you just get Coke. So lame. You get what? Strawberry lemonade? Is that in the machine? I thought you had to order the strawberry lemonade special. Yeah, you do. Yeah.
I just put all of them in there.
Barf.
It's like a fake lemonade. It's not like
Yeah.
the actual lemonade.
No, I know.
It's like a strawberry lemonade in the machine.
Oh, is there one in the machine as well? See, I didn't know. Oh, that's interesting. That might be worth having a look at. Okay, are we good?
It's like it's Minute Maid.
All right, page 109. Now, again, it looks like a crap ton of work because the questions go all the way to 112. But there are a lot of pictures. Do some of them. In 15 minutes, we're supposed to go out to the rotunda. When we get back from that, if there's time, we'll play the word game for gummy bears. And I have another cool math game that my brother and I used to play. Some of you can play it if we have time. If we don't, no big deal. All right, so you got 15 minutes to work right now. Now, please notice, this is the last section of the unit. So what are we doing Monday? Our review. What are we doing Tuesday? No, we mark the review. So what are we doing Wednesday? Test. And Wednesday for you people is... Oh. No. Wednesday is cool. You guys have this class second block. But remember, next week you are doing that numeracy assessment. I can't remember which day it is.
I think he said November 3rd. I'm pretty sure it's Wednesday.
Well, November 3rd is Sunday, so I highly doubt they're calling you in on Sunday. I think you guys are the 5th, which means Monday I'll show you some of the questions. There is no way to study for it, so you needn't worry. What? Oh, yeah, I was looking at Thursday. Sorry, yeah. But regardless, last block is fine too. All right? So, Monday, I'll show you some of the types of questions you'll be dealing with. Okay? And you're going to see and you're going to be like, this is it? I'm going to be like, yeah, that's it. You're going to be all like, really? I'm going to be like, yeah, really. Okay? Ask Brody. It's not hard. Right? Brody, is it hard? Not particularly. See? Meg, is it hard? Maggie says not at all. See? What?
It doesn't look bad. Like, it doesn't matter.
Literally, you can't fail.
Okay, but like,
No. Listen to me. Of course it looks bad for me, but nobody's ever cared about how it looks for me. It doesn't actually look bad for me. What it looks bad on, when you see the questions, you're going to see that it makes every single teacher you've ever had teaching you math look bad. Actually, it makes me look the least bad because I'm doing stuff that's way over and above what that test is testing. So who it makes look bad are you for not remembering how to do things that you learned in grade 5 and your grade 4, 5, 6, 7, 8 teachers. But it really doesn't make anybody look bad because, of course, it's barely even a math test. It's much more a test of your ability to read. It is almost an English test with some numbers thrown in. You'll see what I mean. If you can't wait, if you are so, oh my God, I can't believe I have to do this, you can Google BC numeracy assessment. Something like that. Yes, it's got the word ass in it. Something like that, and you will get some sample questions. I mean, I'm going to do that anyway Monday. But some of you may actually be bothered or worried by this. But I'm telling you, if you write down any answers, you pass. Okay? The only way is to not write it. All right? Okay.